Okay? So our next topic right after our geometric sequence is our geometric mean. So by definition, the terms between two given terms in a geometric sequence are called geometric mean. So between the given terms. So if you are given a geometric sequence, like for example, you are given for the first and the last term, then you are asked to solve for terms in between the first and the last term. The term in between is called geometric mean or are called geometric means. So what does this mean to us? When we talk about mean, that is basically the average or the terms in between the terms. Okay? So what we're going to do is we are going still to use our formula a sub n is equals to a sub 1 r raised to n minus 1. We will not do away with our geometric sequence formula. So say for example, I have here, let us try to solve insert two geometric means between 4 and 500. Now, if you're asked to solve for or insert two geometric means between 4 and 500. So, the question here is how many means that we're going to insert between 4 and 500? We're going to insert two geometric means. So, our sequence, our geometric sequence will be like this. 4, blank, blank, and 500. Since we're going to insert two terms between our 4 and 500 to form our geometric sequence. So what we're going to do here is we're going to use our formula again. A sub n is equals to a sub 1 r raised to n minus 1. Now, since we're talking about means here, we're going to solve for this. And what is provided for us are the first term and our last term. Now, our first term is 4. The last term is 500. And we have how many terms all in all? We have 4 terms in a sequence. So therefore, we're going to use all of those information and substitute that to our formula for us to solve for these two terms here. But we cannot directly solve for the terms here because our goal is to solve for the common ratio. And after which we have solved for the common ratio, we're going to multiply that common ratio to our first term to get the second term, common ratio multiplied to the second term to get our third term. And by that, we have inserted two geometric means between 4 and 500. So how are we going to solve for that one? Again, our a sub n is the last term, and that is now 500. Is equals to a sub 1 is 4. Now, we didn't have r yet, so that is why we will still copy our r. N is now identified because we have how many terms? 1, 2, 3, 4. We have 4 terms minus 1. Then simplify first this one. We are going to copy 500 is equals to 4. R, 4 minus 1 is 3. Then divide by 4. And this will be cancelled out. What is left is r cubed. 500 divided by 4, and that is 125. Then get or extract the cube root. This will be eliminated. What is left is r. So r is equals to the cube root of 125. What is the cube root? Cube root of 125. And that is 5. So therefore, the common ratio is 5. So what are we going to do next if we got the common ratio 5? Multiply 5 to our first term. 5 times 4 is 20. 20 times 5 is 100. 100 times 5 is equal to 500. So therefore, the terms inserted are 20 and 100. Okay? So that is very easy. Now, how about if we are asked to solve for this one on our example number 2? Now, example number 2 is, all you have to do is find a geometric mean between 5 and 45. So, you're going to insert a geometric mean. So, it means that you're going to insert only one. Okay? Only one mean between 5 and 45. So, therefore, what this means to us is 5 blank and 45. So, we're going to insert only one mean between 5 and 45. So, there are two ways. So, I'm going to show you first the first method. Then, I will show you again the shortcut method if we're going to find the geometric mean or insert one geometric mean between terms of our geometric sequence. So, again, use the formula. A sub n is equals to A sub 1 r raised to n minus 1. Okay? And, since our A sub n is given 45, that's the last term, A sub 1 is 5, r, n is the number of terms, so we have 3 minus 1, n, 1, 2, 3, and we simplify, this is 45 is equals to 5, then this is r, 3 minus 1 is 2, divide by 5, so this will be cancelled out. What is left is r squared. 45 divided by 5, what is the answer? That is 9. And get the square root of this one. So this will be cancelled out. What is left is r. So the square root of 9, we have two integers. That is positive and negative value. Positive and negative 3. So that is the common ratio. But positive and negative 3 is not yet the term to be inserted. We will have to solve. And we will have to multiply this one to our first term. So we have two possible answers here. So 5 times positive 3, and that is 15 times 3 is 45. Or we can have 5 times negative 3 is negative 15. Negative 15 times negative 3 is still positive 45. So we have two possible answers. Again, you can have an answer of 15 or you can have an answer of negative 15 to be inserted to our geometric mean between 5 and 45. Now, I mentioned earlier that we have another method. So the method is this. The formula is this one. B is equals to the square root of AB. Now, if A, B, D forms a geometric sequence, we can say that B is the geometric mean of A and D. It means that our B is at the middle and these terms here form a geometric sequence. And the formula there is B is equals to the square root of the product of the first and the third term. Okay? So that is the geometric mean is equals to the square root of the product of the first and the third term. So let us use this example that you're going to insert a geometric mean between 5 and 45. So, let us simplify. So, our A here is 5 and our D is 45. A is the first term and D is the third term. And B is the second term, or this is our mean. Okay? So this will be the square root of the product of our first and last term. So this is 5 and 45. So what is 5 times 45? Okay? What is 5 times 45? So that is 225. So this is the square root of 225. Okay? So what is the square root of 225? And that is positive and negative 15. So therefore, we still have 15 or negative 15 as possible answers, and they are just the same answer but different solution. But this one is a shortcut method since we are not going to solve for the common ratio, but Instead, we are going to solve directly, solving for our main, but that the special case that we're going to insert only one geometric mean between terms. Okay? So, I hope geometric mean is clear to us. And by the way, shout out to the owner of this one, Ma'am Ana May Matugas Corsillas. Thank you, ma'am. Okay, so that ends our geometric mean lesson. So I hope you didn't have questions, so just review our video so that it will be clear to you. Next topic is geometric series.